Hello everyone, welcome to Elite Engineer. In this video, we are going to see the incremental and conductance, a maximum power point tracking technique that is applied to the boost converter. In the previous videos, we have already seen that how we have implemented perturb and observe maximum power point tracking technique to a buck, to boost, SEPIC and zeta converter. In this, I have covered the converters that is basically ignored by most of the research papers, or we can call YouTubers if they are trying to explain. So before I explain you about incremental conductance maximum power point that is applied to the boost converter, I'll explain you the configuration and the connection, how it is connected, right? So this is my solar P panel that is generating approximately 301.928 watts of power. If we check the PV curve and IV curve, we can clearly see that at 25 degrees Celsius I'm getting around 301 watts of power, and we can clearly see that the current that I'll get on maximum power. This thing I have defined here in this configuration module. I've selected this as a user defined, like I want this rating solar P panel that is available with me, right? Accordingly, I've just selected my MPP voltage, MPP current, and open circuit voltage and short circuit current. Number of cells per module also I can select. If you already know which solar panel you are selecting and it is already available in MATLAB, directly you can click here and it will give you the output according to the module you have selected. So I'll just click it OK. Now the output of the solar P panel will be connected to the boost converter. We already know that the configuration of the boost converter. There is an inductor, there is a switch, and then there is a diode, and output there is a capacitor. Now there is an input capacitor. We already know that how we can calculate the inductor and the capacitor values based upon my input voltage and output voltage, right? It's already given in the formulas. Okay, and if you are not aware of that, I'll just mention the link in the description below, and that will redirect to the website where you can find the detail of the book I have used for calculation of inductor and capacitor values, right? Now what I need here is to track the maximum power from the solar PV. I need to feed the pulse here to the switch so that it can extract the maximum power from the input, right? Now the output of this is V0 I0. That's okay. Now what happened here is I'll just consider the input of the boost converter, or we can call the output of my solar PV, and I'll feed it to the zero order hold, and then it will be given to the incremental conductance maximum power point tracking algorithm which I have written. Now this is the initial duty, maximum duty, D minimum, and the delta D. According to that, I've written some of the code, and then what happened here is it will generate the duty, right? Then it will pass to zero order hold, and then it will generate the duty. Now to operate this boost converter, I need the pulses and not the duty. Hence, I will give the input duty to the pulse generator, and then it will generate the pulse, and that thing I'll feed here to the boost converter. Now let's operate it and just check how my incremental conductance is working. I'll just open the scope for checking the maximum power point tracking. See, this is the transients that is coming, this one. And now it has reached to steady state, and now the pulse is, this is oscillating maximum power. It will, every time it will oscillate. Whichever configuration you will take for maximum power point, it will oscillate around maximum power point tracking, maximum power point. Because it will not stop at single point. It will just track the curve like this. For example, if there is irradiation change, like some partial shading condition occur, then there is a change in the maximum power, and again it will reduce, or if it is a partial shading and earlier it was partial shading and now it is fine, 1000 watts, and then from lower power it will go to the higher power, and then again it will oscillate. I'll show you in the upcoming videos how I'm considering the partial shading also. For this part, I'll just stop it here because I've just explained you the incremental conductance when it is applied to the boost converter. If you need the simulations for this this simulation work, you can directly click on the link given in the description, and it will redirect you to the website where you can just download the simulation file developed in MATLAB 2018 version. Thank you for watching this video. I hope to see you in the next video.